This lesson continues 4.1 from the textbook and talks about functional notation. So functional notation is pretty straightforward. It's just the simple notation that if we're looking for an output y, we can also define it to be a function of x. And this is written as a function of x, meaning x is the variable that we are plugging in to the equation to solve for y. So I have a few examples here, and I apologize, sometimes the negatives don't always show up on my screen. I have a few examples here, and in this case we have y equals 5x minus 7, so in functional notation we would just write it as f of x equals 5x minus 7, and essentially all we've done is replace the y with f of x because we're defining this to be a function that we want to use over and over and over again. One thing I will warn you about is to be careful. I know there are parentheses here, but this does not mean multiplication, so we cannot use the rules of multiplication. This means a function of x. So in this case, if we wanted to write some of these out, we would just say, okay, well this is f of x is equal to 3x squared minus 9x plus 17. And again, all we're doing is replacing y with f of x. And this last example, f of x is equal to the square root of 2x squared plus 9. So, as it's noted here, this is a useful abbreviation for our notation. Instead of having to write out every time that we have an equation and what we want to plug in for it, we can just give the equation and ask for instance, f of 4. So in this case, we would plug in 4 anywhere we would see x. So again, x is just a placeholder, and we are plugging in whatever is in parentheses into that placeholder. So let's try a few examples of that. I've given you this function. F is not the only letter we can use. Often G and H are also used to define functions. So if we have the function g of x is equal to 20 minus 4x, we want to find the following. First, we want to find g of x. So again, anywhere we see x, we're going to plug in this number in parentheses. So in this case, we are going to have 20 minus 4 times 6. So we end up with 20 minus 24, or negative 4. Another example, if we wanted to find g of 0, same function as before. We say 20 minus 4 times 0, which just comes out to be 20. This last example, g of negative 3, well, we have 20 minus 4 times negative 3. So this is 20 plus 12, which is just 32. So again, all we're doing is we're taking the number that's in parentheses and plugging it in for x. X is our placeholder. You can replace it with a box, with pretty much anything you want, just as long as you remember that it is a placeholder. So let's try another example. Given that h, like I said, f, g, and h are the common ones that we use for functions, common letters that we use for functions. If h of t, t can also be our variable. As far as variables are concerned, we use x, y, z, t. Those are the common ones. Given that h of t is equal to the square root of 20 minus 5t, we want to find the following. We want to find h of 1. So again, we're going to be plugging in 1 where we see t. So this is going to be the square root of 21 minus 5 times 1. So we end up with the square root of 21 minus 5, and again, we have to make sure that we do everything inside the radical first. We can't split that up. And then we have the square root of 21 minus 5 is 16. The square root of 16 is 4. Try another example here, h of negative 3. So we plug this in, we get 21 minus 5 times negative 3. So we get the square root of 21 plus 15, which is the square root of 36, which is just 6. Let's try one more example. We don't always have to have whole numbers that we're plugging in here. They can be fractions, decimals, square roots, all sorts of things. So in this case, we're going to plug in 21 minus 5 times 8.23, and take a second to figure out what that is in your calculator. So you end up with the square root of 21 minus 41.15, which comes out to be the square root of negative 20.15. Now, we talked about before whether or not you can take a square root of a negative number. When you want an answer that's a real number, this is considered to be undefined because of that negative under the square root. This would actually create what's called a complex or imaginary number. And we'll talk about that a bit more. You should have talked about that in Tech Math 2, but we'll talk about that again in Tech Math 4. We don't always have to necessarily have functions per se. Sometimes we can have graphs and be able to figure these out, because technically all of these are equations that can be plotted to find different points. So in this following example, and I'm going to zoom out a little bit just so we can see everything a little bit better. So in this example, we've got a graph of two different functions, and each function has some questions asked about it. So the first one is this upside down parabola, and the first thing I asked for is f of negative 5. So what does that mean? F of negative 5, this again is your x value. So you want to go on the x-axis to negative 5, and then follow that down on the graph, and then follow that over, and in this case it comes out to be negative 22. So you want to find the y value that corresponds with the x value of negative 5. Let's try another example. If we want to find f of 2, we go over here on the x-axis to find 2. We follow that down to the graph, follow the graph over, and again you want to be very careful that you get a straight line. In this case it goes over to y equals negative 2. So in this case f of 2 ends up being the y value negative 2. We can also kind of go backwards from this and say, okay, well, when does f of x equal 3? So in other words, which x value gives us a y value of 3? And so we've got to be careful which way we're looking at this. If the number's in parentheses, then that's our x value. If it's equal to that number, then it's our y value. So we want to know when y equals 3, and it's kind of up here, what's your x value? Well, if you look here, it's really at an x value of 0 because it's on the axis. So I want you to take a second, pause the video, and try to find the answers for this next graph. Okay, so for this graph, if you look at the x value of negative 4, that's actually where the graph crosses. So in this case, that's pretty simple. It's just a value of 0 because it's on the axis. Whereas f of 4, we're over here, we follow that up, and that is at a value of 6. So again, those were giving us x values because those were in parentheses and we were finding y. These next two are giving us the y values and asking us to find the x. So when does f of x equal 4? I'm going to zoom in just so we can see the axis, maybe not. But essentially on this example here, if y equals 4, so again we're on the y-axis now, our x value is actually just 0. In this case we have to write x equals 0. These ones we were giving a y value, so we could just put equals the y value. In this case we have to define that x equals 0. And the last example, when does f equal 6? So when does f equal 6? It's a whole lot of values here because this is a straight line. So in this case it would be x greater than, if you follow this down, 2. So any number greater than 2 on this is giving us a value of 6 because we've got a constant function at this point. And that can happen. You can, for a function, like I said, you can never have more than one y output for a single x output, but you can have several x outputs producing the same y output. In this case, that's what you have, or x is greater than or equal to 2. This next set of examples talks about what happens when you want to plug in other variables or combinations of variables, because it's not always numbers that we need to plug in, and when you get into calculus, you'll see this a lot. So, in this example, we're given a function, f of x is equal to 8x squared minus 7x. We're going to do the exact same thing. Whatever is in parentheses gets plugged in for the placeholder x. So, in this case, if we want to plug in z anywhere we see x, we just end up with 8z squared minus 7z. It doesn't look like it changed a whole lot. All we did was replace x with z. And sometimes that happens. Usually, though, you're doing something a little more complicated, like this next one. Now, instead of x, we're going to write 2y. So we've got 8 times the quantity 2y, and we're careful to put that in parentheses because the whole thing is getting substituted in, minus 7 times 2y. So if we simplify here, we've got 8 times, well, 2y squared. We have to make sure that we distribute, and we end up with 4y squared. Minus 7 times 2 is 14y. So our last step to simplify, 8 times 4 is 32. Y squared minus 14y. And then you can just leave your answer like this. Got a few more examples here. We have what happens if you want to plug in this sum. And again, like I said, we cannot use the distributive rules. This is not multiplication. We cannot distribute f of a plus f of 3. That is not the same thing, and you'll see why when we actually go through and simplify this. So in this case, we plug in the whole thing, a plus 3. So we have 8 times a plus 3, quantity squared, minus 7 times a plus 3. And again, remember, when you're squaring here, this means that you're multiplying it by itself. So this would be 8 times, and we had that formula for the binomial theorem for Pascal's triangle. And this becomes a squared plus, we multiply them together, we get 3a, double it, you get 6a, and then you square the last one and you get 9. Minus, if you distribute the 7, we can distribute there because there's no exponents, you get minus 7a minus 21. So we can simplify again, we end up with 8a squared if we distribute, plus 48a, plus 72 minus 7a minus 21. And if we simplify one last time to combine like terms, we end up with 8a squared. The 48a minus 7a is going to be plus 41a, and 72 minus 21 is going to be plus 51. And so that's our final answer, simplified. I want you to pause the video at this point and try this last example. See if you can come up with the same answer. So if you look at this example, again, you're plugging in the whole 3t squared. It's going to be 8 times the quantity 3t squared squared minus 7 times 3t squared. So if we square that whole thing, we end up with 8 times 9t to the 4th minus 21t squared. And then if you simplify, you end up with 72t to the 4th minus 21t squared. And that is the expanded form of the function.